Everyone, thank you for joining us this evening. I'm Nick Luson with Norcal Premier Soccer. This is actually the first of what's going to be a series of fall webinars that we're going to do on kind of different areas in club development on Wednesday evenings. We'll be sharing some information that kind of breaks down the full list. Next Wednesday at 7 p.m., we're going to have a presentation around the AB5 independent contractor law and the new exceptions that the state has recently passed and how that does or does not apply to your soccer club and paid coaches. So we're going to have Monica back, who presented her AGM on that topic. But for this evening, we have a very timely subject, unfortunately, but it's obviously something a lot of us are struggling to work with on our sides. So the folks here, our friends at Sonoma Technology, have reached out and kind of we're aware through their soccer connections that a lot of our clubs are kind of in the dark on how to best make decisions when it comes to AQI. So we felt this would be very, very useful to people. So I'd like to turn it over to the staff at STI. And if you want to introduce yourselves and your roles there, and then you're welcome to jump in.
Yeah, wonderful. I'll kick us off. I will, from the Sonoma Tech side, I'm a host and co-presenter to the Air Quality Resources for Youth Soccer Decisions, and I'm joined by Hillary Hafner. We'll introduce ourselves a little bit more formally here. We'll go ahead and get the presentation started. You do see as a panelist another senior scientist with us, Olivia Ryder, who's going to help a little bit with the Q&A. She does not have an active speaker role. So let's get started. A few sort of openers. Disclaimers are the usual that you would expect in this type of health and safety related presentation, that we are providing this information for informational purposes with no warranties or guarantees. All these sources of information are fundamentally subject to change, although a lot of it is established science and will not change by tomorrow. We want you to make use of this material. We're currently working with Norcal Premier to distribute it after, but for the time being, we would appreciate if you kept it for your use and the use of your decision makers on your respective boards, and not repost and widely distribute it to your membership just yet. When we endorse, you remain solely responsible for the decisions you make for your club, and although we're going to give you some excellent guidance today, those decisions are ultimately your responsibility. When we mention a product today, we are not endorsing it. We are simply talking about it as fact. And likewise, when we mention government agencies, we're not endorsed by those government agencies. So that's sort of a little bit of front matter there. We'll get much more interesting in a second. For the Zoom webinar, we will be using there's a Q&A function. So if you have questions, please use your Zoom functions to ask a question. And during the Q&A section, we will then answer that and read them off and answer them and record the answers. We're also, in a couple of minutes, not to distract you, but we're going to launch a quick poll with about 9 questions that let us understand how you feel about a number of things, and that's then going to be shared with everyone, including Norcal, for us to make better decisions. So with that all out of the way, let's get started, because this is actually fascinating subject matter. It is, like Nick said, very timely. And while my opener here is that, first of all, today we all can breathe a collective sigh of relief, because across the area, as this screenshot shows, which is actually data from this morning, the air has cleaned up significantly. So that is good news. And while we wish that it was like that all the time and that there were no protocols needed, it seems to be that come fall time in Northern California, this is a new normal. And no-go decisions look more like this. And the air quality map looks more like this. And so sadly, the blue skies, at least in the fall time, are not our normal. So the agenda today will be a quick set of introductions. We'll talk about what is really the problem, and the front end of the presentation is education for you to understand the complexity of the situation and for you to become educated around the phenomena that we as air quality scientists work with, we want you to be aware of. And then we're going to walk through some health impacts, but ultimately the meat and the heart of the presentation and the value for you will also come in the resources we want you to rely on that we want to point out to you, and basically some decision-making protocol suggestions and the takeaways at the end. So with that, I think it's proper to introduce us as a company, and I'm going to turn that over to Hillary. and let you take over.
Great, thanks. Hi. So I've been at Sonoma Technology almost all of those 35 years, but not quite. And we are a consulting firm that applies science and technology to help answer air quality questions. And we have clients all around the world. We're headquartered in Petaluma, but we also have staff in offices across the country. And primarily we do a lot of different things, but we've really focused on air quality and meteorology. We do a lot of software and tool development. And then pertinent to this conversation today is we do a lot of work with fire and fuels modeling and smoke modeling. So that's going to be pretty important for us today as we go along. So a little bit about me. I really do a lot of training and data analysis and presentations, talking to state, local, and tribal air quality monitoring agencies, try to help them figure out how they're going to measure air pollution, understand it, and improve their air quality. And then I don't play soccer, but I swim on a local masters team, and we're having the same issues with trying to, in the morning, decide whether we can get in the pool or not because of the air quality. So we're all kind of stuck in that same situation. And then I'm not really competing anymore, but I have been doing all these glorious swims off the coast of in Europe, and it's been really, really fun to do a swim vacation.
Great, thanks for that, Hillary. I have created technology for a very long time, including starting and growing and divesting of a software business. So my role at Sonoma Technology is to turn a lot of the knowledge that we have into tools and products ultimately that will help people live better lives. Personally, my strong connection to soccer is that I'm from Germany originally. Experienced is always relative, because I know we have coaches that have coached for 20 years. So I'm a relatively experienced coach, this should say, where I coached for 6 years competitively and recreationally. And I think more pertinent to this webinar, I have actively helped run a soccer league. I was vice president and president of Sonoma Valley Youth Soccer for 4 years. So I'm pretty familiar with the types of discussions that happen in the soccer boardroom, the pressures that we face in terms of executing programs, keeping kids safe, and realizing that something like this is in essence a very unwelcome distraction, but something that we cannot ignore. So that's the point of view that I want to bring. In addition to science and technology, I bring that point of view here to the discussion. So let's cut to the problem and really get started. Current wildfire and smoke events, it's clear that they show to us that things are highly abnormal in terms of air quality, and coaches and league officials simply realize and are overwhelmed by the fact that they're not air quality scientists. Organizations in general are unsure, what information do I really use? How do I make decisions? Who should make them? And a lot of organizations struggle with the content and the timeliness of the messaging to their members and their staff. We're not just messaging to one constituency, but often to multiple constituencies. So with that agenda in mind, what we're now going to go through is several major sections. The first of which is basically some air quality and health fundamentals. And I'm going to turn it over to Hillary for that portion and then come back in.
So air pollution is quite complicated. I have a master's degree in chemical engineering focusing on air pollution. So, we've in lots of years of experience, but so there's a lot of moving parts to air pollution. And basically we've sort of separated things into two regimes, if you will. Sort of routine air pollution, where it's more of a regional nature. It's pollution that we know where it's being emitted. We know the magnitude typically of those sources. We know what time of day those concentrations are going to be highest or lowest. We know how the weather affects the pollution. And we're major components for air pollution that we're concerned about here would be ozone, and then particulate matter of various sizes from 1 micron to less than 2.5 microns to 10 microns, and then nitrogen dioxide. So what I want to let you know about our routine air pollution here in the area is that overall the trends in this regional level of pollution have greatly been improved by the National Ambient Air Quality Standards, and concentrations have steadily declined since the year 2000. So we actually live in a very pretty good air in this area, which is partly why my company is here, so that we're breathing the right air. And then finally, we also understand sort of how the pollution is formed, how it's transported, and then where we might expect to see higher concentrations now and then. In contrast, we're going to focus a lot on exceptional events. So where we're talking about something like a wildfire. These can be both regionally, actually right now nationally, because there's smoke getting all the way to the East Coast and heading out towards Hawaii, and then very localized as well. The major components that we're focusing on here is smoke is particulate matter dominated, but it also elevates nitrogen dioxide, which is another irritant to our respiratory system. And then other kinds of pollutants like volatile organic compounds or hydrocarbons. And ozone can also be formed from some of the emissions from the fires. However, we're going to focus on smoke here because that's really what's driving the air quality index that we'll be talking about a little bit later. The source locations and strengths are very variable during the fires, as you hear all about how much contained they are or where they're moving. Large fires even create their own weather. And then also fires out here, we're seeing them during exceptional meteorological events, such as super high, strong winds from the east, and then dry lightning, which is what started the August fires. So there's again, we're talking about very less known, or more complicated situations when we're talking about fire and smoke. So we're wondering what's in smoke, and the composition of smoke is highly dependent on what is burning. So you can imagine that when a town burns down, it's a lot different than just burning trees or grass. And then it also matters how efficiently the fuel is burning. So are things really, really dry, or is there some water that would make things burn differently? We care about what the wind and weather conditions are. Again, is it hot and dry and windy versus cooler? Because we kept talking about how the smoke was slowing down, or the fires were slowing down as the temperatures have declined. And then also it matters for your body where you are relative to where the smoke is. Did the smoke travel a long way to get to you? It's going to have been aged, and there's a different composition of it than it is when it's right next door. And I want to talk a little bit dive into particulate matter. So this graphic here is basically showing a human hair. It's a drawing of a human hair, and the size of particulate matter less than 2.5 microns is that first lowest row. So like soot, organics, metals. So very, very small particles, as you can see. We can't see them individually. And then coarse particles are things like dust and pollen and mold, and those are particles that are less than 10 microns or so. So it shows you relative to your hair what size these particles are. So we're talking about very, very small particles. This is why they're dangerous, because they can basically go deep into your lungs and even get into your bloodstream, which is shown here. Basically, the health concerns with fine particulate matter are that it can aggravate any lung disease that you might have, such as asthma and bronchitis. It increases your susceptibility to infections, can aggravate heart disease, and has led to cardiac arrhythmias and heart attacks. And they also, some of the fine particles can cross the blood-brain barrier and get into even deeper into your body. And the illustration here is just showing that when you breathe in, the larger particles, like PM10, make it down through your trachea, et cetera, but don't go deep into your lungs. That's where the smaller particles are going. So what does this all mean? I think now we're starting to hear or get more familiar with the term air quality index, or AQI, and it's basically set on the National Ambient Air Quality Standards that I talked about earlier, and all of the data that goes into NAAQS to set the standards that are meant to protect human health. Those standards are based on data that was collected at 1 hour, 8 hour, or 24-hour averaging periods. And most of the health studies that are tied to setting the air quality standards are based on these longer average data. And so actually right now, we still don't have a very good sense of the actual health effects of very short-term high concentrations of pollutants, like 1 minute PM 2.5 data. We don't have the health information that ties along with those concentrations yet, but that research is proceeding, but it's relatively new. So the AQI is basically set up, it's that indicator, and it essentially is to give you an overall view of the air quality in your area. And it could be, on some days it might be that ozone was the highest AQI, and so that's what you're seeing. And sometimes it's PM 2.5, which is what we've been seeing lately. An AQI of 101 corresponds to the level that's violating the federal health standard. So that's basically saying that it's higher than what we feel is protective of human health. And if you see green, which is good, basically, we don't need to worry about, like today, it was beautiful. We didn't have to worry about our breathing. If you get up to unhealthy for sensitive groups, for example, the orange, and again, these are the official Air Now, EPA Air Now AQI colors. You can be people that are at higher risk that, like, let's say, have asthma or something, might want to reduce their activities according to the EPA. And I will tell you that I have mild asthma, but if it's unhealthy for sensitive groups, I definitely have a hard time working out in it. So I've definitely noticed that. Unhealthy starts to affect everyone, and very unhealthy, obviously, it's like stay in the house, have filters around you, etc.
And my just interjection here also is that mind the language here, that heavy outdoor exertion. So by its very nature, when we ask athletes to go out and practice sports, we are inhaling much greater volumes and exchanging much greater volumes in our lungs. So it's not like going to school or taking a walk. It is an increased exposure. So that's a special call out here.
Yeah, that's a good point.
I did, and this is thanks to one of the early responses that I got in questions. I will take this slide. Somebody had asked about ash, because commensurate or together with the orange guys the other day, we got large amounts of ash, and somebody was asking about that. So ash, while it's a particle, it's a large particle. Studies that we have looked into at a cursory level indicate that, or at least one study showed an average size of ash at 230 micrometers. So I just wanted to point out that compared to what Hillary showed before, that is much, much larger than what we consider the PM particulate matter. So this is not something that's going to enter deep into your lung. However, it's very abundant. The photo here shows a fabric. I had multiple sessions, I would say anecdotally, where I hosed off objects and things around the house, and there are little mini clouds of ash that came off. So there's a high volume of this. It is composed of carbonates, hydroxides, and various other mineral and metal oxides. And I think what's very important is what Hillary mentioned earlier, that the source of the combustion can have probably a very direct impact on what you find in it. So if we have residential with lead paint burning, you would get different ash particles than in a wood fire. So together with the fact that in a chemical study, when you dissolve ash in water, which is essentially part of what happens when we get it on a wet mucous membrane, it turns into a very basic, that is caustic material. And so I think, in short, without wanting to scare folks, I think it's fair to say that ash in larger quantities will act as an irritant to skin, eyes, and throat. And I think our recommendation would be, in any heavy ash concentration, to hold off on heavy exercise. The question I got particularly, that because it is so much larger than the other particles, ash and ashfall is not actually measured by the PM network. So you could, on one day, we did see very orange skies. We saw low yellow AQI values and lots of ash falling. So that's a combination you can see. So AQI is simply not a measurement of ash itself. So that was a special call out.
All right, so you're leading into a little bit of how do we measure particles. And historically, government-sponsored locations had very expensive instruments, which we're going to call regulatory monitors here, available to measure air quality. The reason why they're called regulatory is that these are used to see whether or not that location is meeting the national ambient air quality standards. And so these instruments are tens of thousands of dollars. They've got lots of quality controls on them and highly skilled technicians that take care of them. And so they're very different than what we're now going to call low-cost sensors. And those are being increasingly put out by non-government, and some small government as well. And they're deployed by private citizens and organizations, and they're getting that data out there, like Purple Air. Purple Air is actually the one where the hands are in the screen there, screenshot.
Right.
And I should mention also that at the top of the regulatory monitor, I don't know if you can kind of circle that there, Bastian, the inlet.
Yeah.
It's basically sized so that it's only going to bring in either PM 2.5 or PM 10
This one right
particles.
here?
No, it's the top. Yeah, there you go. Yep. So that inlet is basically limiting the size of the particles, because again, we're focusing on what is harmful to human health when you breathe it in. And so those are going to basically not bring in something like ash. They're only going to bring in the smaller particles that we showed compared to hair. Okay.
And on this next slide, and remember the last two photos that we showed. So some key differences are that regulatory monitor is extremely accurate. As you saw in that photo in the previous slide, they're usually specially sited, meaning they are very carefully placed at a location that is protected, secure, has unique characteristics, and professional staff maintain, calibrate, and service them. And as such, you can imagine that the cost of these sensors, deploying and running them, is very high. And while people have kind of sort of in the complaint quadrant, how come there's only one every 20 miles? Well, that's because of this level of effort. And so the low-cost sensors, then, as opposed to that, they can be deployed by you tomorrow. You can order one. You can hang it anywhere you would like. You could hang it under a tree. You could hang it on your porch. It's sited by a non-professional, and you could leave it there for 2 years without ever touching it. So there's no element of quality control, maintenance, of servicing. So they're really just in very different categories, but they're both valuable, as we'll see in a second. They're very valuable each in their own right. And why we want to call these out in such a way is that later in the resources that we're going to talk about, especially on one of the key resources or maps that we recommend, you will see special symbology, each corresponding to what type of sensor it is. So we will have a circle and the triangles that denote some form of permanent or temporary regulatory monitor, and we'll have little squares that denote all these low-cost sensors. So that's why we go into that in this detail. So, in a virtual webinar, again, if you have questions, feel free to use that Q&A panel. We're going to roll right along because we still have a lot of ground to cover. So I'm going to go quickly through weather/meteorology and cover that. In general, and we're not, in an hour here, we're not going to turn anyone into a full-fledged meteorologist, but in some ways, weather and meteorology are very accessible to us through our direct experience. Weather really phenomena occur on multiple scales. We call it one of the macro scale. This is what the meteorologist opens their forecast with. They show you the weather map, a high and a low, a front, something the size of Oregon and California, and tomorrow we'll have a cold front, or we have a low pressure system, or we have something that causes stagnant air in the entire Northern California. That's what we call the macro scale. At the mesoscale, then that's something that would be at the scale of the Bay Area, the Central Valley, larger regions that are dominated by a phenomenon. And on that scale, we can see things like sea breezes. In the Bay Area, we have very strong marine layers, daytime onshore flow, meaning wind coming from the ocean to the land at considerable speeds. At night times, sometimes we have land breezes where that reverses and air flows from the land to the water. And then at the smallest scale, at the micro scale, we have things such as warm air rising along a hillside during the day and cold air flowing down a hillside at night. And that creates micro scale effects. So that would be the kind of effect that you take a walk in the evening and you feel a very cold downburst of air. The Sonoma Valley, Napa Valley, foothills of Vallejo or anywhere, micro scale effects. So these all really act together. And the reason we bring that up is because you'll see in a minute, we're driving really to one topic here. But before we get there, this is just a depiction of one of the, I would say, prosumer wind tools. This is not something that that you have to be a scientist to use, but it showed two different snapshots, one from earlier in the week, Monday at 1 a.m., where the dark colors indicate stagnant air, really little airflow, and then a forecast for today, which I think generally held true, that shows, you know, considerable wind speeds and flow from the north to the west, kind of flowing through the Bay Area. And we can all sort of see that that contributes to really, in the end, all of these meteorological phenomena contribute to what we call smoke transport. And that then can happen over short ranges. I mean, this shows a map of a mountain range with a plume emanating from one of these fires in this region, you know, very confined. So if you're right here, you're going to get very localized smoke. Then we see a national image. This is again from the last week. This is from a smoke forecasting model, but it depicts fairly accurately the extent of smoke. But we see that we have fires. Their extent goes all the way from California into Oregon, and Oregon fires that extend all the way into Washington. So we're talking massive spatial scales, right? So all of that really goes to, I'm gonna have to clear these drawings here, goes to that all these meteorological phenomena work together to create what in meteorology and in pollution we call temporal, that is variation over time, and spatial variability. And the image on the left here shows one sensor measurement over time, over the course of 14 days, 4 days from September 10th to 14th. And we see the trends over time. Pollution goes up rapidly, it stays high, it decreases, it goes up again. So that's a temporal, a trend over time in one location. And then over here we see is a spatial distribution that we see very distinct sort of clustering patterns, that we see a high here, we see moderate values in San Francisco, lighter values in the North Bay, and very, very dark reds against the foothills. Again, these things are the combination of the meteorology, of the local fires, and all of these things sort of working together in what Hillary referred to earlier, whereas standard or routine pollution, we understand the trends a little bit better. In these smoke events, we get a high degree of variability in time and in space, and that makes the situation a little bit more difficult. And that's why we're going to point towards these resources here in a minute. Just another illustration here, that place and time matter greatly. These are the same snapshots for 3 different instruments across the North Bay, the Northern California region, where we see vastly different trends, right? Again, these are the same days. This is September 6th through 14th. North Bay, very clean for a while, rapid increase to high values, purples and reds. Davis, muttering along with a couple of events, and then at the same time, Lincoln north of Sacramento, relatively clean early in the week, and then kicking up. So there's sort of no one size fits all. That's a key message here. And let's start looking at our resources. Now, one of the other questions I got early on was, well, how about trends? Can we spot the trends? Can we like maybe look at things and figure out when things are going to clean out? And I would give a qualified maybe, but it's maybe a little bit more akin to the stock market, where when I look at last year's stock chart, I can sure tell which stock was going to do great in April. But here it's difficult. So this is one time series where we see temporary decreases and then an increase. This is another case where there's a very clear trend towards a cleaning that I think many more people could have spotted this trend and maybe predicted somewhere in here that things were going to clean out. So trends are a bit deceiving in that, yes, we can tell, especially with this low-cost sensors, fast changes. In certain cases, we may be able to tell a cleaning trend, but as I showed before, there's a lot of complex information in there. And so that's why we're going to get into what we recommend more as a standard set of resources and what to use. So the most important section really is that the one that we're going to spend the next 15 minutes on, which is, so what then do we recommend? What do you look at and in what fashion? And what do we use as tools? And this is we start with an overview. I know there are a lot of resources, and I know a common tendency for all of us nowadays maybe is to Google air quality, AQI, and you know the ones that float to the top. I would say resist that urge, because there are some wonderful resources that are very reliable that we highly recommend because of their validation, qualification, and reliability. So on our short list, so to speak, are federal government provided resources, then EPA Air Now, and we've divided these into real-time and forecast, and we'll talk about that a little bit more here in the remainder of the presentation. If you're trying to make a decision on a shorter time frame, you would certainly like to have access to information that is sort of now, what's happening now, what didn't happen 6 hours ago. EPA's Air Now website and app have relatively real-time information. The information there is, depending on the sensor, 1 to 2 hours old. So it's relatively new. And those resources also have forecast information. Local agencies throughout the Bay Area, such as the Bay Area AQMD, Air Quality Management District, Sacramento Spare the Air, and if you're as far away as Southern California, it's South Coast AQMD, they also have local websites and resources that in their own ways present both some real-time and some forecast information. And then we divided this a little bit. The commercial resource that many people refer to and we think is very valid is Purple Air. That provides very real-time information because you can get almost up to the minute information from Purple Air, but we'll talk about and qualify a little bit how we would recommend using that. So that's at the overview level, the types of resources that we really recommend primarily relying on. So we're going to go through each of those here now. So on the federal side, EPA Air Now is really a core resource. It has a website and an app, and on those pages, and we'll see different views of those pages, you get a very quick current AQI indicator for your area. The app and the website both localize to your location, and they'll give you the AQI where you are at that time. That same page, we'll show that on the next slide here, that same page also has forecast information further down. So you can really get a quick snapshot of both the present and the forecast all in one resource. Notice that even on this dial here at the bottom, we have a very quick look of today and tomorrow. So compact view. There is a resource that they have modified a little bit that has become very valuable. And I would say maybe for me, and I don't want to over-personalize this, but has become one of the primary resources that I use and actually prefer over Purple Air, is the fire.airnow.gov map. It is a map that actually combines the regulatory monitors. Remember the symbology we talked about? We have circles, triangles, and squares. So I can see regulatory grade monitors, and I can see the small sensors, and I can see all that spatial resolution all in one map. The key benefit of that map is a correction factor applied to the Purple Air data, and we'll talk about that here 4 or 5 slides from now. So again, in summary, EPA's Air Now resource is really high quality, very reliable, and something I would routinely include in your data scan. This is just a view of the forecast page section on Air Now, where we get multiple day forecasts, and you can get visibility over a number of days. And then yet another view, once you click into Air Now, there are map renderings. Now you'll notice that they have less nuance on these maps than say in Air Now or other tools, but the approach that these agencies take is to do a generally representative forecast level for a larger area, and they don't include, I would say, a degree of nuance that other tools seem to imply. And I think they're very valuable. They're great guidance for understanding what's happening in a map sense. Notice that from a user perspective, there are also ways to modify this map and show different forecasts on this map. So this is a great mapping resource. So then in addition, we went through our resource list in the beginning. In addition to that EPA Air Now resource, many of the local agencies across our area also have their own pages with some unique data displays. For example, one that I would recommend taking a look at that somewhat simplifies and subdivides the area in the North Bay and the Bay Area would be the Bay Area AQMD page that we're linking to here, where we have essentially a zonal forecast. And I'm not showing that here, but when you click onto this map, it actually gives you a 3-day, 4-day, 5-day forecast, I believe, for that zone. So that is a nuanced resource from a forecast perspective. Over on the right, we're showing a different page on the AQMD, where AQMD just shows their regulatory monitors and the values that they have measured in the recent past and the present. So these are great resources. Likewise, for Sacramento and the Central Valley, we have the Spare the Air website that has various displays of, again, maps. These maps all use the same color code. This is very important. Notice that on all these maps, we use consistent color codes. Orange, yellow, and purple mean the same things that Hillary showed on the AQI chart, and you're not getting a customized visualization where red all of a sudden means something totally different. That's an important factor in these. So I shouldn't say elephant in the room because it's actually pretty tiny, but the topic that we hear about all the time is purple air. How should I use purple air? Everyone uses purple air. Actually, what spawned some of this is somebody sent me a purple air map saying, we're not going to do this today. And I said, whoa, wait a minute. Let's talk about this. Purple air, what is it? Purple air is a network of these small sensors. And Hillary kind of already introduced that. These images are from purple air. It's basically a plastic covering. And inside that plastic cover are two particle sensors that work together. They both measure the same thing. Individuals buy them, they hang them on their porch, they operate them, and inside that little device are two light scattering laser devices that measure particles. And they report that data real time to the data system that is called the purpleair.com website that you then see each sensor on the map with its reading. And that's what purple air is. It's its own little air quality network. So some specifics about purple air usage, and if you've ever used this, you will find this. So first of all, when you use the purple air map, there's an important, very important consideration of using a correction factor. In the little tile that's at the bottom of the map, there is a drop down next to the parameter that we're viewing. So this is PM 2.5 that says no correction, AQNU, and LRAPA. We have actually a definitive recommendation that you should use AQNU because that has been found right now to be the most accurate correction in smoke conditions to bring a purple air reading to be comparable, not the same as a regulatory monitor, right? These are correction factors. If you're curious about these are correction factors where basically an organization or a group took a purple air, compared it with a more sensitive or valuable or high-grade measurement and tried to correct one using the other. And there are different groups that have done this. AQNU is out of the University of Utah in the Salt Lake region. LRAPA was actually done by the Lane Regional Air Protection Agency in Oregon, who simply compared purple air readings with a regulatory monitor in smoke conditions and came up with their own correction factor, right? The question we've gotten separately and that Nick asked me to specifically cover at the beginning here is that there is now discussion because on the EPA map that I shared with you a minute ago, the fire.gov map, they are showing purple air values with a special EPA correction factor. And from what we're hearing, that correction factor may be published and may be included in the purple air tool. So in the future, you may see an additional correction factor. And I don't know how that will be labeled. We don't know the timing of that. We would recommend using that. The other thing that I would caution you is that while purple air defaults to a 10-minute average, I would be cautious to compare these averages to basically figure out, am I seeing a 10-minute measurement or am I seeing the representative measurement for the last hour? So play with those values that's one tip. The second tip for purple air, and it may be really obvious to everyone, but I keep making the mistake that you look at a map and you see a number of green dots, and what you're actually looking at is some inside sensors because people can deploy these in or outdoors. So make sure that you deselect indoor sensors. And we'll go into this in more detail, but we would definitely want to be suspicious of what we call outliers. So a value where there is many reds and a green, I'll cover that in a special slide. So I definitely want to transmit the message that I would primarily rely on the government agencies, but that in parallel, purple air, if used appropriately, can be extremely useful. So in this case, this is actually a snapshot from last night where I turned on the AQNU correction, I turned on 1 hour averages, and I turned on a little feature that amplifies each sensor to be more of a ring to cover the area. And I started getting a sense that there is a cleaning from the west starting to happen, which lo and behold, that when we then look at the EPA forecast, which came a little bit later just because of their scheduling, very much reflected and reinforced that trend. So this would be a great example of where you could use these tools in combination to make an observation, fortify that observation, and then make a decision. So Purple Air definitely is a great tool. Now back to the outliers, and this again to us air scientists, this might be obvious, but I took a Purple Air snapshot in Novato last week. These are 3 sensors within the same neighborhood. And as we can all tell, 2 of them agree brilliantly well, and 1 of them is completely out of whack. And despite all the quality control that's happening, even with EPA and small sensors, I am suspecting, I cannot prove this, that the sensor that shows all green may possibly be mislabeled and maybe in somebody's living room. And certainly the message I want to transmit here is that as a coach, you would not say, oh, my soccer field is right next to the green dot, it's safe to practice. So I'm hoping that we aren't that simplistic, but I think that should be called out. So I want to close out this section with really guidance that gets us towards the close of the presentation, which is really how do we make decisions. So from a resource summary perspective, looking at the same resources we started with, there are resources that support real-time decision-making. So when we look at Air Now, we have very reliable data that really, in the grand scheme of things, only has about a 2-hour lag. On a forecast basis, Air Now resources have very broad and general information that's really applicable and good for conservative decision-making, I would say, and we'll cover that in a minute. And I think all those properties are true for the local agency resources as well. Where commercial resources like Purple Air come in this summary is that they do in a way provide the most up-to-date real-time information, and they can help you if you know how you use them. And I apologize for the error, but for wins only is actually an error, and you can ignore that. That was from something different. So with a few minutes left here in the 45-minute presentation part, and then we want to open it to more Q&A, I want to talk about something much more important in a way than just the science and the tech behind all of this, and that is decision-making protocols and how we translate this information into actions. Now, I am also very open to potentially working with Norcal Premier on developing these further to where they're a bona fide protocol. That's certainly in the cards for us. We haven't fully discussed that, but all of you clubs may be looking at some version. I also wanted to compliment one of the clubs that actually already sent me a version of their protocol, and I thought it was very well thought out given that they were not air quality scientists. So let's get to that. I think it's very important for an organization, and as a former president, that's taught me that we make some fundamental decisions up front. We need to make a prioritization decision. Am I fundamentally, do I want to be a very conservative organization where my prime directive is protecting all the sensitive members? I may even want to find out who's got asthma in my club, or maybe that's been in my enrollment or registration questionnaire. In that case, if that's my overall decision-making prioritization, I will then make decisions and protocols that are very conservative, that prioritize safety at all over any perceived risk, and it may come at the cost of maximizing some practice time. Or am I an organization that is willing and able, I think that's important, to make calls that are maybe risky in a way, that you've called practice and it's drifting from yellow into red. What do you do then? I believe that prioritization will take more effort to get right because you have to look at more resources. You have to make the call quickly. You have to react more quickly. You have to message more quickly. To me, the foundation of the prioritization protocol is to be consistent. I cannot be prescriptive here. Your organization has to find what's right for you. But both as a scientist and an league administrator, I would feel it very important to be consistent, to use the same protocol every day and not make a decision based on a forecast one day and then quickly call practice the hour before the next day. That would be one realm. The other realm of decisions is simply is choosing a scheme of timing and data sources. If I'm in a forecast driven, and really these are aligned, like forecast driven is conservative, then I look at the forecast in advance. I choose the forecast from one of the agencies. I pick it. I say, they're forecasting a particular value tomorrow. That's the decision I'm going with. Or I choose to be a near real-time organization. Then I need to look at Purple Air. I may have to have somebody look at winds. I may have to compare a lot of data sources. And the key question there are you ready and equipped and staffed to make the call, to communicate the call and to act on it? And then really, is your organization staffed for that? And in all of that, to me, the bedrock, the underpinning principle is choose reliable data sources. Use the same data sources every day. Don't use data sources that look better than others. Go with established data sources. Developing a communications protocol is always an issue for us in clubs. I'm sure you will work on that on a daily basis. Again, my recommendation and guidance would be message consistently. If your protocol has been established that you don't send any message when practice is on, then be sure that you have communicated that protocol and everybody knows when I'm not getting a message, practice is on, and when practices are canceled, I get an explicit message, right? Communicate proactively. Some clubs that I've seen have done a great job at keeping a message in there saying, hey, and if your child is in a sensitive group, has asthma or bronchitis, make the right call today, just as a reminder, right? And in communications, I think it's super important to keep in mind that not all members will have their email ready. And when you send an email out an hour before practice, that may not reach all your members equitably. So, and then we're kind of landing right on time here for our 45-minute segment. I think everybody at the end, when we do the field training, the coach's best practice is always to kind of summarize, what did we learn today? Did we learn kicking or passing or dribbling? And so the final takeaways here are, we ask questions at the beginning, what information to use? Our recommendation is to use vetted, reliable data sources. Use EPA Air Now and use your local agencies. Use Purple Air by all means and implement the caveats that we discussed. Look for data correction, realize that they are small sensors and that they're not as accurate. How to make decisions. Make decisions either well ahead, make that call, be conservative and be forecast-based, or if you're going to make decisions in near real time, then again, my recommendation or takeaway is by all means strive to do so, but be sure that all of your protocols allow that to be a reliable decision and consider the communication and your member actions in making those decisions. I omitted the slide, but in one of the discussions online, a soccer mom member posted, hey, what you didn't think about in all of this, that I'm in the middle of my day and I'm rushing around and I'm taking one kid to piano lessons and all of a sudden I get the call that practice is on or off, and that's tough. So that's a resounding message that we need to all take home. And the last question that we asked in the beginning that we'll answer is, who should make the decisions? Well, keep in mind, none of us as sports enthusiasts, sports professionals, league administrators, none of us are trained meteorologists. So be sure that the staff that we have in place at least are trained on these whats and hows that we're talking about here. And I want to be sensitive to this not being promotional, but if any club and or Norcal want to work with us to develop this further, we're more than happy to do so. I want to close with also the thought that, again, without being promotional, self-promotional, that over the long run, as an organization, we would love to develop tools and technology that make these types of decisions easier. So we're very much looking forward to those members and Norcal Premier for us to work together to figure out what makes sense at the technology level for each club and each organization. So I think that kind of brings us to the close here of the presentation. I mean, in closing, I really wanted to thank Nick and Norcal for putting this on. Of course, I really also want to thank all of our attendees for participating. And I think we had online, I'll review real quick, the questions that I can see here online. I'll bring them up. And they are, our air district uses RAAN. Is that a good tool? So this is a question answered out of the San Diego region, it seems to me, or San Joaquin. Hi, Carol. Olivia says, yes, the RAN tool is produced by the San Joaquin Valley Air Pollution District, so it will also rely on the regulatory monitors. So this is good news because we're using a valid data source. And Olivia adds a note that one item that she's not sure about is the frequency. Actually, Olivia, if you're on, why don't you, can you see the Q&A?
Can I see the, yeah, I answered the questions.
Yeah, you did. So I'm sorry,
So
then I think it may be much more efficient for you to kind of go through those and your answers. That may be more efficient.
Sure. One question that I think would be helpful for everyone to hear, and maybe Hillary would be, or you, Bastian, would be the best one to answer this, but Jack has a question. He says that the none and the AQ and U settings for the purple air give similar readings numerically. And if you could talk a little bit about the difference between the two, because there has been a lot of discussion about those.
There has been a lot of discussion, and unfortunately there are multiple things that complicate my answer a little bit, and Hillary can chime in if she wants. First of all, some of the information that is being discussed is currently proprietary and within the EPA. I just have to say that. That is one answer. So I don't want to reveal that. The correction factors that have been developed for the purple air and AQ and U in their kind of scientific, the way that they were developed scientifically are very similar. They basically compare the purple air to a reference instrument and they try to establish a correlation between the two. There are very different approaches for doing the correction that take other data into consideration. And so in this particular case, there may be cases where AQ and U and LRAPA might produce similar results in one scenario, but keep in mind that we've been in one scenario for a while. If there's a different scenario with different smoke or something, we may actually see stronger differences between the two. And I know, Hillary, it sounds like you want to chime in, so maybe you have other things to say there too.
Yeah, I think that my understanding of the LRAPA was that it's not very good when the concentrations go very high. That it is under predicting high concentrations, which we've had extremely high concentrations. So that was something I heard, and that the EPA's method, which is why I keep going back to that fire and air now fire and smoke webpage, is that they have looked at various concentration bands, bins of concentration, and have applied actually different correlation and corrections in each of those bins of concentration, so that it seems to better represent a wider concentration range.
Yes, and I would say it's fair to say that an ongoing debate, even within the air quality community, is whether there is such a concept of a local sort of smoke mix that is in one area that you would have a correction factor that is more applicable to, say, a Bay Area smoke event than an Oregon smoke event. There's discussions around that. That just hasn't been resolved. So, some people have suggested there should be a regional correction factor for each region. Others say that may not be the case, and we may well be able to establish a single correction factor across all bands. For now, I think the key takeaway is don't look at the uncorrected values, because in smoke events, the native sensor in the purple air simply over-reports the concentrations that it shows you on the map
by as much as a factor of 2 or more.
Yes. And so the best analogy that I thought of the other day as I was explaining it to my kids, actually, so those of us who've driven in snow, you can kind of tell the intensity of snowfall by how bright the light is in through your headlights, right? And if you now design a sensor that measures that, if all of a sudden it gets brown snow, you would get a totally different perception of the density of the snow ahead of you. And that's sort of in the direction of where we see the errors, and it just needs correction. So I'm sorry I can't be more specific there. And I know, Jack, you have asked great questions already, and you guys were the organization that had a really good protocol. So kudos back to you. We can't answer that with more specificity. So keep your eyes peeled. And I think as soon as we know, we'll be happy to share that. Yes.
I was going to say there was no other questions in the chat.
Okay.
Well,
I think.
Yeah. So hey, I just want to say, thank you to everybody. Thank you to Sonoma Tech, to Hillary, Olivia, and Bastian for sharing this with us. So it sounds like we will have the content from the slide deck that we'll be able to share. We have our library of resources on the Norcal website that we'll be putting this up to. If you don't mind, I would like to share my screen real quickly. I think, Bastian, you might need to